You clicked on this video because you are tired of exporting massive CSV files just to debug signal noise with remote teammates. That frustration stems from the fact that file-based workflows create latency bottlenecks when you need real-time visibility into autonomous systems. By the end of this explanation, I will reveal why browser visualization solves your immediate pain points while exposing a critical architectural trade-off regarding security and production-grade data lakes that most engineers overlook. The core issue is not how fast you can transfer files across the internet or within your local network. The bottleneck occurs when you attempt to render interactive signal noise in real time using traditional desktop applications like Excel. These tools often fail catastrophically with large-scale datasets, forcing you into a cycle of exportation and re-exportation that destroys temporal context. When you open a massive CSV file on your machine, the application must load every single row into memory before it can display anything useful. This process introduces delays that make debugging impossible when signals are changing rapidly or when noise patterns require immediate filtering to isolate anomalies. Consider what happens during a remote collaboration session where two engineers need to analyze the same telemetry stream simultaneously. One engineer exports data, sends it via email or chat, and waits for the other person to download and open it locally. By that time, the system state has changed. The version control chaos inherent in passing massive CSV files between teammates means you are always working with stale information. You lose the ability to dynamically filter or graph signal noise without starting over from scratch every single hypothesis test. This friction loop is not just annoying, it actively prevents team alignment and slows down engineering velocity significantly. The solution lies in specialized browser viewers that utilize virtualized rendering engines designed to handle massive datasets instantly. Tools like Spud's 0588 CSV Quick View or the legacy Recline Chrome CSV Viewer demonstrate this capability by loading over 100,000 rows without crashing your browser interface. These extensions intercept file URLs and render data directly within the web environment, shifting the performance bottleneck from input-output latency to simple frame rate limits of the rendering engine itself. The result is immediate visual feedback where you can zoom into signal noise, apply filters on the fly, and share a specific view with colleagues without ever touching a disk drive or waiting for file transfers. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. However, this convenience comes with significant architectural constraints that define its limitations in production environments. Browser-based visualization tools typically operate as client-side Chrome extensions rather than server-side analysis platforms. While these extensions can intercept HTTP streams to enable real-time visualization, they cannot fully override native operating system handlers due to browser security policies. This means users must manually click links or configure specific file access permissions every time they want to view a new dataset. You are not getting a seamless zero-copy streaming experience across all contexts because the web platform itself imposes strict boundaries on how local files can be accessed and processed by extensions. This fragmentation extends beyond technical limitations into market adoption realities. High-performance local viewers like Visalins exist, yet many tools remain niche within the engineering community. The original Recline Viewer repository holds only 37 stars, indicating limited widespread integration into standard engineering pipelines despite its utility for specific debugging tasks. Furthermore, cross-browser compatibility remains a significant barrier to creating a unified collaborative solution. A port of Rufus Pollock's work known as Mozilla CSV Viewer highlights that the same extension often fails on different browsers or requires distinct installation procedures depending on whether you are using Chrome, Firefox, or Edge. The critical realization is that building tools solving specific file-based pain points creates higher immediate value than generic data analysis platforms because it directly reduces cognitive load from context switching between local files and remote collaboration. When an engineer can switch from a static spreadsheet to an interactive browser view in seconds rather than minutes, the entire debugging rhythm changes. The ability to maintain temporal continuity means you stop guessing about signal behavior and start observing actual system dynamics as they unfold. This shift transforms how teams approach autonomous system failures by allowing them to react to live data streams instead of analyzing historical snapshots that no longer reflect current conditions. Yet we must acknowledge that this browser-based pattern does not replace robust centralized data lakes for production-grade debugging workflows. The reliance on extension-based interception and varying security policies prevents these lightweight tools from scaling into enterprise architectures where massive datasets require persistent storage, complex querying capabilities, and rigorous access control across distributed teams. For signal noise analysis in real-time scenarios, the latency of uploading or downloading gigabytes of raw data often exceeds the computational cost of local browser rendering, making zero-copy streaming a superior pattern for team alignment during active debugging sessions. But once you move beyond immediate troubleshooting into long-term archival or deep forensic analysis, the limitations of client-side processing become apparent. The trade-off is clear. File-based workflows fail at scale not because of transfer speeds, but due to the inability to render interactive signal noise in real time without external dependencies. Browser visualization tools eliminate this friction by allowing engineers to interact with data streams directly within their development environment, bypassing the export-to-disk loop entirely. This approach enables immediate collaborative debugging where multiple team members can view and manipulate the same dataset simultaneously without version conflicts or stale information. However, the lack of a unified cross-browser standard and strict security sandboxing means these tools serve as powerful adjuncts rather than complete replacements for traditional data infrastructure in high-stakes production environments. Understanding this distinction allows you to choose the right tool for the specific phase of your engineering workflow. During active debugging or rapid iteration cycles involving signal noise, browser viewers provide unmatched speed and collaboration features that file-based methods simply cannot match. For long-term storage, complex historical analysis, or regulatory compliance requirements where data integrity and audit trails are paramount, centralized systems remain essential. The most effective engineers leverage both approaches strategically, using lightweight visualization tools to solve immediate problems while maintaining robust back-end infrastructure for the broader lifecycle of autonomous system development. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.